Alright, this is page 6, and I know it looks kind of funny because I have two different color of paper here. This is the Andrea Portraits page, and I made a mistake here and I had to get a different piece of paper. So this is going to be B and C, and I actually want to do C first because it's going to make more sense if we kind of flip-flop these around. So we're going to do C first. C says to determine the constant of proportionality and explain what it means in the situation. So we've got to find that constant of proportionality, and we have to explain what it means. So we know that constant of proportionalities are K, and moving this out of the way for a minute, we know that we can find that constant of proportionality, that K, by doing the Y divided by the X. Back over here again. So I know I could take my Y values and put them over the X values. Now that I'm using a graph, that'll be really helpful. These were all of the Y values right here, and these were all of the X values. And if you think about it, it's going to make more sense to talk about the amount of portraits per hour in this particular case. I mean, we could see an argument for doing hours per portrait, but we're going to go with portraits per hour for this. So we're going to take Y values of 3 and 6 and 9, and then we're going to put them over their corresponding X values. We're writing ratios here. I kind of did that weird, sorry. 3 is going to go over 2, 6 is going to go over 4, and 9 is going to go over 6. We're just going to find out what those each equal. 3 divided by 2 is 1.5, 6 divided by 4 is 1.5, and 9 divided by 6 is 1.5. So we have just discovered that K is equal to 1.5, which we're going to need because we're going to have to write an equation up here. And it says also to tell what it means in the situation. So if you remember, we were taking all of these Y values. That was all of the hours. I'm sorry, that was all of the portraits. And we had those all over the hour values. And so when we did 1.5, that would be portraits per hour. So we would say that 1.5 is the amount of portraits in 1 hour. So we just explained what that 1.5 meant in this problem. And then we're going to go one more step further here, and we're going to go back up here to part B, which would make more sense if we did it after we did what we just did. It says to write several equations. I'm going to change that to write an equation. We're just going to write one that would relate the number of portraits drawn to the time spent drawing the portraits. So we're talking about portraits to time. And as soon as you hear equation, hopefully you're remembering what we've been talking about the past couple days. We want Y is equal to KX. And once we have that, Y equals KX, all we have to do is take the K value that we just found, which was 1.5, and put it in place of that. So Y is equal to 1.5x. And then the last thing we have to do is just replace these values here, these variables, x and y, with variables that make more sense in the problem. And the good news is, because you're dealing with a graph here, your x is what's going on here on the x-axis. So here's the x-axis, and that is the time spent drawing the portraits, and they already have a variable for you there to use, which is t. So these x values here, we're going to use t as your variable, and those are your times. The 1.5 stays with that, so 1.5 was multiplied by all these x values. 1.5 would be multiplied by all the times, and then that would equal the y, and in this particular graph, the y is the number of portraits that are drawn, and they used n for that. I probably would have used p, but whatever works. So n, the number of portraits, is equal to 1.5 times the time. So 1.5 portraits in an hour multiplied by however many hours would give you the number of portraits. And you could see that by looking up here in your graph. If you were spending 2 hours, 2 for the time would be 2 times 1.5, which is 3. That's your number of portraits.